I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 29th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making big waves in the North Pacific Ocean, and of course a quick look at snow potential along the U.S. West Coast. Let's get to work. First off, we'll take a look at significant wave heights for the North Pacific Ocean. We see a broad storm generating 42-foot seas pushing over the international dateline. Most of this energy all aimed off to the east. Sideband energy at Hawaii. Large swell is in the water, pushing towards all locations along the U.S. West Coast and the Hawaiian Islands, and even further south than that. This is a great way to start off the new year. So to start off, we'll look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. The jet stream is very consolidated, a single flow pushing the whole way across the Pacific Ocean. Winds to 190 knots here off of Japan, feeding into this, a trough, and that's exactly what you want to see, a big, broad trough, a dip in the jet stream pushing to the south. That helps create a counterclockwise flow aloft and at the ocean surface. That is the hallmark of low pressure, and we certainly have low pressure right over here in the Dateline region being fed by this strong jet stream. Of course, low pressure at the ocean surface generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a good trough providing excellent support for gale development in the upper and lower levels of the atmosphere. And that trough goes almost to the western Gulf, and then we get the exact opposite in the Gulf, a ridge, the jet pushing to the north. That does the opposite, creates high pressure aloft and at the ocean surface, and of course that doesn't do much for generating swell. Then we have another little tiny trough trying to organize off the U.S. West Coast, probably not doing anything to support, swell production, but precipitation and weather into the U.S. West Coast. Light rain falling in San Francisco today, but nothing too over the top. Let's put this into motion, see what happens. Trough continues as we get into Monday, looking pretty good, getting slightly weaker. This backdoor trough, actually is a trough that was off the West Coast, now sort of moves inland, but part of it hangs off the coast off of Point Conception as we get into Monday, falling south. Now again, this isn't doing anything to promote swell production, just maybe some weather down into even Baja. Now notice as we get into Tuesday, the trough starts pinching off. You get a new trough starting to develop inland over Russia, probably not doing a whole lot. We'll put this into motion, see what happens. Energy levels start really dropping in the jet off of Japan, but building as they push into the U.S. West Coast, mainly Pacific Northwest. That's probably more of a weather producer there than anything. We're into Wednesday, we go into Thursday. The jet starts really weakening over the Dateline region. Looks like it potentially wants to split. Big ridge building off the U.S. West Coast. That probably means north winds there, driven by high pressure. And here we are into Friday night, almost a week out. The jet splits, not heavily so, but enough to really just shut down support for gale development in the main western Gulf Dateline region. Maybe a little trough here in the northern Gulf of Alaska, providing some support for gale development, but nothing too extraordinary. And then where are we? We're at Sunday now. We're almost a week out. Big split here over the whole eastern part of the North Pacific. Trough develops. Notice this pretty tight little trough here on Sunday off the Kuril Islands, being fed by 140 knot winds, offering some support for gale development, but way off to the west, probably not doing a whole lot for swell production. Another tiny little trough setting up come Monday or late Sunday in the northern Gulf. But basically, after the storm that's currently in the water now, it looks like things are really to settle down. Energy levels drop in the jet. The jet sort of unwinds or unzippers and starts splitting over the eastern part of the Pacific, and that doesn't do a whole lot to support gale formation. All right, let's go take a look at what's going on at the surface. Here we are, surface level pressure, surface level winds. We see the storm. It's down to gale status now. 40 knot winds there. That's the effective fetch. This 45 knot winds here is aimed really nowhere. So all the energy that we're concerned with is right here. 35 to 40 knot winds over a pretty good solid area, aimed off to the east, generating seas that we saw. And we'll just put this into motion, see what happens. You see the gale fading, and by midday Monday, it's all but gone, down to 20 and 25 knot winds. That's doing nothing. High pressure setting up off the U.S. West Coast, probably generating some north winds there. Gale tries to organize over the Kuril Islands, but is going nowhere. Another gale develops in the northern Gulf on Wednesday with 40 knot winds way off to the north, doing nothing for Hawaii, probably targeting the Pacific Northwest. We also have this little cutoff low that develops here north of Hawaii on Wednesday night into Thursday, generating 45 knot winds, supposedly aimed south at the Hawaiian Islands, but moving off to the east pretty quick. Maybe some wind swell, we'll say, for Hawaii from that. And then everything, it looks like it's trying to coalesce here in the Gulf come Friday. This is actually better than what the models looked like just 6 hours ago. Pretty broad fetch of 30, 35 knot winds. A secondary fetch here. Maybe making wind swell come into the weekend for California. 30, 35 knot fetch continues into Saturday. And then here we go. Oh, interesting, on Sunday. This is looking a little bit better again than the last run of the models. Not only is there a gale forecast for the northern Gulf with 40 knot winds, but a broad gale again setting up off Japan with 40 to 45 knot winds, looking very solid as we get into late Sunday night with 50 knot winds, stalling, not making any eastern headway. This is a significant upgrade from the models just 6 hours ago. Do we believe any of this? No, not at all. Not even a clue. But because, well, one, it's 7 days out on the GFS model, so you never believe that. And two, it's only been on this one run of the model. So maybe after 3 or 4 days, if it's still hanging on the models, then we'll say, yeah, maybe there's a chance this will happen. But at least it's a step in the right direction, looking positive. So let's take a look at the effect of these winds on the ocean surface. Now, we're actually going back to Friday because, well, there's a big storm and we need to understand all the details. So here we go. Friday, 18Z, that's about 10 a.m. California time. The gale started organizing off Japan with 40, here's the maximum seas over this entire domain, 42.5 feet right there. That's literally nothing compared to what happened as we get into late Friday night. Seas built to 55 feet. And then we got into Saturday morning, 58.7 feet. And then 18Z Saturday, that's where this storm peaked out. 59.3 foot seas over a good solid area, targeting Hawaii up into the U.S. West Coast, down into Baja, and probably even down into mainland Mexico. Long period swell. When you get seas this high, you're going to expect 22, 25 second period swell. This is not a low energy swell. It will not be held off by anything, even opposing winds. So, and this has already happened. Anyway, we get into Saturday night, 57 foot seas. Oh, end point. Let's go back here. So significant wave heights, okay? With significant wave heights of 59 feet, that means that once every hour, there is an individual rogue wave somewhere in this area that's twice that size. So we're talking 118-foot individual rogue wave once every hour somewhere in this area. You do not want to be in a boat, or you did not want to be in a boat on Saturday in there, because if you were, you're probably not there today. All right, anyway, moving on. Sunday. The storm pushes over the dateline, or pushed over the dateline, 53-foot seas, down to 48-foot seas at 12Z, that's 4 a.m. California time, and and as of right now, is fading with what we saw before, 43-foot seas over, if you just saw this and didn't even see anything before this, you'd look at this and go, there's solid swell coming, and this is just the fading remnants of what was a pretty strong and impressive storm. So then we move into the forecast. It pretty much looks like this storm has done its damage away from California. That's 2,400 nautical miles, much closer to Hawaii, but not on the main track. So it wouldn't be surprising to see equal-sized swell at both locations. Anyway, put this into motion. You see as we get into Monday, this thing fades out. Now again, we still have 20, 22, 24-foot seas just about filling, we'll say, the whole northern third of the North Pacific Ocean. Pretty impressive indeed. Anyway, that fades out. Most of this, again, is from previous fetch. You can see, in fact, let's go back. You can literally see, here's Hawaii, here's the swell front, or the raw sea front, if you want to call it that, hitting Hawaii on Monday. Very solid indeed by Monday night. Most of this looks to be hitting overnight and then fading as we get into Tuesday morning. You can also watch the energy pushing into California come Wednesday. Small gale develops at that time in the northern Gulf. This is like a pittance compared to what we were looking at, 30-foot seas. But yes, it'll make swell, more swell. I mean, we've had a pretty good run, over the Christmas holidays. We've had at least two, if not three swells up in Northern California, been well overhead. Pretty raw conditions, pretty bumpy, but, you get what you get. Swell is better than no swell. All right, we move into Thursday. The cutoff gale that's forecast north of Hawaii is to produce 24, 25-foot seas, we'll say. And, yep, there we go. Continuing into, let's say, late Thursday night, putting some swell in the water. Now, here's where things are going to get interesting. Let's see what happens. New gale forecast for the northern Gulf, producing 27-foot seas on Friday night, aimed well at the whole U.S. West Coast into, 27-foot seas continue. Then let's see what happens. Oh, in the Gulf again, another patch of 30-foot seas. I mean, this is looking pretty impressive indeed. And we'll just go to 180 hours out, and boom, there you go. 42-foot seas off to the west. If that forms, that would produce swell for Hawaii and the U.S. West Coast. The Gulf continuing pretty active with 26-foot seas there. So it looks like, really, if the model's correct, there's going to be no rest at all. Continuous swell in the water for the foreseeable future for most locations. Not a bad Christmas present. A quick look at JSON 3 data. So we haven't shown this before, not much. We've talked about it some. So this is the actual track of the JSON satellite as it passes over the Pacific Ocean. You see the track is very thin. The odds of it ever actually passing over a storm are pretty thin, but we got lucky. On 18Z Saturday, it passed over just a little bit ahead of the leading edge of this storm. Seas were supposed to be, what is that? About 18C Saturday. Oh, it's the peak of the storm. 59-foot seas. We had an average, 15 reading average of 45 feet with one reading to 53.5 feet right in here. So the satellite is saying seas were not quite as high as what was suggested by the model. But then there's also a 2-hour time differential here because all this happened at like 16Z, and this is the 18Z run of the model. So we're going to say, yeah, maybe the model's overhyping it a little bit, but still, then we'll knock off 2 feet, and maybe we had 55-foot seas here. Still not bad. And then we got another pass at 06Z on Sunday. That's late Saturday night. This one just behind the main fetch. 15 reading average, 44.6 feet, with a peak reading of 50 feet, where the model suggested it was about 52, 53-foot seas. So again, model about on track, maybe overhyping it by 2 feet. But once you're above 48, 50 feet, it's all sort of splitting hairs. There is long period swell coming, no doubt. So let's take a look at wind forecasts for the coming week. GFS model again, you see high pressure, 1032 millibar high right here. High pressure, winds circulate clockwise around it. You can see that quite clearly. And we'll just put it here to the 0Z. That's where we are right now. Weak low pressure right here, a 1016 millibar low, creating a weak gradient with the high here, a little patch at 20-25 knot winds off the California coast, but near shore, light southerly winds. Hawaii under the influence of trades at 15 knots solid. All right, so that's our calibration point. Let's go to Monday morning. We see, again, kind of a light flow along the California coast. Trending northerly over outer waters, probably be a bump in the water. Trades, for the most part, normal, 15 knots out of the east into Hawaii. Then we go into Tuesday. We see, and this is, again, trades, 15-20 knots for the Hawaiian Islands. It's certainly better than north winds for the arrival of the swell number 2, that is. And California, again, a pretty light flow near shore, but pretty brisk off the coast. Then we get into Wednesday. Then it looks like high pressure starting to ridge into the California coast. 15-knot north winds. Trades weakening for Hawaii. And we see the fetch building north of the islands, the other fetch in the Gulf that we talked about earlier. Thursday, 20-knot north winds along the California coast. Just can't be denied. High pressure. Remember, the jet's ridging there, so this is no big surprise. Hawaii, winds looking to be sort of falling apart and maybe building out of the northeast as we get through the day, and there comes a front, looks like pushing through the Hawaiian Islands. That'll pretty much shut down anything for north-facing shores. We get into Friday, winds look to be starting to fade for California and just start blowing hard, 25 knots out of the northeast for the Hawaiian Islands. That's not a good sign indeed. Saturday, California still under the influence of light winds. Hawaii, trades becoming a little more easterly, but still 25 knots solid. That's strong. And then we get into Sunday. Looks like a pretty strong offshore flow for California, if not north, and strong trades for the Hawaiian Islands again, and there we go. All right, so again, it's try to find the swell in between the winds or find your protected little nooks and crannies. Rain and snowfall forecast. All right, so here we are, Sunday night, California. Yeah, light rain, barely falling in San Francisco. Maybe some snow up in the very north end of the state. Not much, if anything, forecast for California. And then the low falls down the coast. Rain for Southern California on Monday. And then actually the system pushes down into Baja, if not off Baja. Things dry out. We'll just start blasting through this. You see all the precip limited to pretty much the North California-Oregon border and north of there. We'll see, nothing really. We're just sort of looking for any hope for snow. It looks like the Pacific Northwest is the place to be. Nothing down even into Tahoe. We're into Sunday, and there we go. So it looks like no significant snowfall expected for California for the coming week. We've been working on the snow models, trying to provide yet more coverage. Mainly, I mean, all this is like the western U.S. and Canada. That's our main focus. This is yet a new one. It's not even posted on the site. This is the whole western U.S. from down Southern California and up into, you get up to Calgary, so you can get Revelstoke and Banff in that area, and Whistler and all that sort of thing. And then just the whole basin out into over east of the Rockies. So we'll just put this into motion. You can see, the model's saying light little snow from this current system for the Tahoe area. And then we know we should be starting to see something building. Here we go, up into the Pacific Northwest. You can see snowfall, and then it all sort of lingers down into even the Denver area and Utah. And that's into Wednesday. Thursday, things back off a little bit. Here comes the next system off the coast, blowing in on Saturday. Again, not making it down into greater California, but doing well for the Pacific Northwest mountains there into Sunday. Now, this is a 240-hour model, so we can squeeze a little more out. But again, do I believe it? No. We're out a week and a half, and things, pretty weak after that. Snowfall potential for Squaw Valley, maybe an inch. Snow levels actually pretty high. Look at this. So the reds would be liquid precipitation. This is the bottom of squall. This is the top of squall. So you get into the new year. If there were precipitation, it would be rain. It dips down. So a warm pattern indeed. This suggests the jet stream is up to the north, and we know that to in fact be the case. And it's to stay up to the north for the next 10 days. So no major incursion of cold air. And then you can see winds, but what doesn't matter if you don't have snow? Let's go take a look at Kirkwood. Not even an inch forecast for Kirkwood. Again, now Kirkwood with its higher base up at 7,800 feet, I think it is, still rain even to the summit at 10,000 feet there if there were liquid precipitation, and a pretty healthy batch of wind, so no hope there. And pretty much the same for Mammoth too. No snow forecast. Snow levels, you can see here, Kirkwood Mammoth even higher at 8,000 feet with its summit at 11,000 feet. And if there were snow, it would only be over the very top of the summit over the next 10-day period. Pretty good amount of wind as well. Let's go take a look long term. What's going on with the Madden-Julian Oscillation, commonly known as the MJO, and the El Nino Southern Oscillation. So first off, the discussion of the MJO, Madden-Julian Oscillation. When in the active phase, it helps feed energy to the jet stream, which in turn helps feed storm development. When in the inactive phase, it does not push energy into the jet stream and sometimes causes it to split and creates problems hindering storm formation. All right, so how do we know what we're looking for? Well, all right, this is the West Pacific here. This is the East Pacific here. This chart, we're going to start with just this one here. This is the equator, the date line, 180 degrees right there, and that is New Guinea. There's a thing we call the Kelvin wave generation area, fancy word for the West Pacific, from 5 degrees north and south of the equator, from 170 west, north and south, all the whole way over to 135 east, this area here. All right, so we're looking, this data, this is from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they do quite well for helping us monitor the state of the MJO as well. All right, so we're looking just at the arrows. Strong easterly winds over the entire East Pacific Ocean, but then, and the whole way to the date line, and then notice just past the date line, the arrows, pretty solid there as well, but coming out of the west. So the winds literally have switched direction. This is a key sign for the active phase of the MJO. Anomalies, differences from normal for this time of year. Yeah, winds are strong out of the east here in the East Pacific, but looking at the arrows, they're not going either east or west, means that's pretty much normal. And it stays that way the whole way to the date line, but then you get into the Kelvin wave generation area. Arrows very strong out of the west, suggesting strong westerly anomalies. That's hinting at the active phase of the MJO. It would be no surprise, given the size of the storm that's on the date line today, that the active phase of the MJO, or at least westerly anomalies here in the Kelvin wave generation area, are feeding the jet stream in a very healthy dose. So what's the forecast? All right, so this chart is the entire planet on one chart. Here, we'll scroll down so you can see. 0 degrees, 180, 360. 180 is the date line. Okay, Kelvin wave the Pacific Ocean starts at about here and goes to about here to 80 west, let's say. That's Ecuador. All right, Kelvin wave generation area is just the western portion of that area, so from 135 east to 170 west. So you draw a line up there in your mind and a line up there in your mind. Okay, this is past history. Now we'll go up, take a look. Here we go. Okay, so this is the Kelvin wave generation area, roughly down in this area. You see there were some westerly anomalies in early December. The blues are easterly anomalies. The reds, yellows are westerly anomalies. We got into, we'll call it, say, mid-December, and we were actually supposed to be in the inactive phase of the MJO. But look what happened. Out of nowhere, westerly anomalies started building, and by December 21st, they were building strong. By near Christmas time, very strong, not long-lasting, but a very strong burst of westerly winds here. That is what is feeding the jet stream today. It is continuing and forecast to hold for about another day or two. And then you notice westerly anomalies back off. Remember when we were looking at the jet stream chart? Remember how the jet stream over the next 3 to 4 days just starts fading and dissipating? That's directly related to this weakness in westerly anomalies in the West Pacific. If anything, easterly anomalies start building in. This looks like the inactive phase of the MJO starting to set up in 2 to 3 days. No big surprise, but here's, if you drew sort of a circle around here, here is the active phase of the MJO moving into the western U.S. Outgoing long wave radiation, OLR, right there. Okay, this is a model. Goes out 2 weeks, 15 days, used for monitoring El Nino. Cloud cover is a component of the MJO as well. Not only westerly winds, but normally there's more clouds than normal associated with the active phase of the MJO. The active phase is like low pressure, and it moves, the MJO moves from west to east on the equator the whole way around the planet. So the blues mean negative anomalies, meaning less sunlight reflectivity off the ocean surface, meaning the active phase of the MJO. This is the statistic model. It suggests the active phase of the MJO is to very, very slowly move out of the Kelvin wave generation area. Remember, that's right around in here through the next 2 weeks. The dynamic model, a little bit different view. This is like the GEFS, the GFS ensemble model. Okay, it suggests basically the same thing. Then the active phase just completely dying 10 days out, only to rebuild much stronger over the maritime continent and starting to back build into the Kelvin wave generation area 2 weeks out. So a bit of commonality starting out. The GEFS saying a little bit different picture. Oops, here maybe we can get them both on the same chart. You can see it here. Different than the statistic model. Okay, so a little bit of a disagreement there. Let's dig deeper. Phase diagram charts, another way of looking at the absolute position of the core of the active phase of the MJO, determining its strength. Okay, so what are we looking at here? This is the whole planet on one chart. This is a different view. We're looking down on the North Pole, and the MJO, active and inactive phase, travel from west to east around the planet, all right, from the Indian Ocean over the maritime continent, that's like Bali, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, so in the Western Pacific. No big surprise. The further the dot is away from this circle, the stronger it is. So this is a very weak active phase, and according to the models, it's supposed to get even weaker and migrate maybe to the Indian Ocean 2 weeks out or somewhere in there. The statistic model is a bit uncertain. The dynamic model says, okay, yeah, we're in agreement. It's supposed to move off to the east, but it's supposed to race off to the east, make it the whole way around to the maritime continent like 12 days from now, and almost be pushing back into the West Pacific 15 days out. So again, bit of a disagreement between the two models. I'm sure that will resolve itself in the next 2 to 3 runs of this model. The CFS model. I really like this because it's painting a picture that is much more favorable to what I want to see. All right, so what are we looking at? Whole planet on one chart. Kelvin wave generation area between here and here. Here is the current forecast. Here's what's happened in the past. You see the reds and oranges are the westerly anomalies. The solid contours like that are the active phase of the MJO. So here we are today in the active phase of the MJO. It's supposed to move out. This is about a week out, so maybe 6 days from now. Pretty much out, moving over California and gone. The dotted contour is the inactive phase building. But the interesting part is westerly anomalies are to hold. Yeah, you get some easterly anomalies in the far West Pacific, but for the most part in the Kelvin wave generation area, which again goes from about here to here, westerly anomalies holding in the area of the date line the whole way through the next month. That would continue to support energy transport to the jet stream, which in turn would support storm production. So we have a bit of a disagreement between some of the models of what exactly is going to happen. The GFS sort of says western anomalies dying, eastern anomalies coming in. The CFS says no, western anomalies are going to hold even though the inactive phase sets up. And then we take a look at the 3-month CFS model, okay? So again, this is the whole planet on one chart, Kelvin wave generation area from here to here going up, okay? Only the forecast is at the top, past history is the bottom. Here's our current, we'll call it a westerly wind burst right now that's occurring on the date line, almost done with. Let's overlay the MJO. Okay, now this model, this version, the dotted contour says this is the inactive phase of the MJO, though we just looked at another depiction and said it's active phase, which means either way, the models aren't sure, but for sure they agree westerly anomalies are in control. And you know what? That's all we care about, because the stronger the western anomalies are, the more they feed the jet stream, and that is evidenced by the storm that's in the Pacific right now. Okay, regardless, we get a week out or so, westerly anomalies fade, but we don't get easterly anomalies. And we were expecting to see easterly anomalies in early January. That's a no-go now. That's a good sign. And then as we get into mid to late January, the active phase sets up with 1, 2, 3 contours, much stronger, pretty solid. This would be another big target to support storm production right in here, though westerly anomaly is not modeled to be very strong. And then you see the active phase fades out sometime, we'll say early March. Inactive phase sets up only one contour, westerly anomalies holding. Interesting. Also note, this area of strong easterly anomalies, we've been waiting to see how this is going to play out. The models never really have much of a handle on it. As of right now, they're saying easterly anomalies pretty strong. This is over in the Indian Ocean. It's almost like a blocking pattern. They're supposed to start weakening come about mid-January. By the end of January, they all but die out. They never migrate over the Pacific Ocean. In fact, let's see. And let's put the low pass filter. Here we go. And so then finally you go, that's good. The dotted contour here, that's basically a high pressure bias over the Indian Ocean. If that were to move over to the Pacific Ocean, one would say, well, that's the development of La Nina. We're not seeing that right now. That's good news. In fact, we see a low-pressure bias, a solid contour, low-pressure bias, basically filling the Kelvin wave generation area as it has for a year or more now. In fact, actually building to almost 3 contours just for like a week in January. But the second contour, it was supposed to fade out in February, even late January. Now the model's changed its mind, said no, not till March or so. So hard to tell what's going on, but we do know low pressure over the Kelvin wave generation area is a good thing. That feeds the jet stream. West anomalies feed the jet stream, and east anomalies, as long as they stay in the Indian Ocean, are just fine with us. So all in all, a pretty good looking pattern setting up long term. All right, enough discussion of the MJO. Let's talk about what's going on with El Nino. We're not in El Nino, but the ocean gives us clues of whether we're either moving towards El Nino or La Nina, or just sort of sitting somewhere in between. All right, so TAO buoy data again. East Pacific here, West Pacific here. These little lines here are the anchor lines on the TAO buoys strung the whole way across the Pacific. The X's are the sensors on those anchor lines. We capture data from those sensors, take some software, use it to fill in the gaps, and you get a profile of the subsurface temperatures on the equator in the Pacific. All right, and these temperatures are in centigrade, so you can multiply that times 1.8 to get Fahrenheit. Regardless, warm water, 30 degrees. It's actually backtracked a little. It was over at like 175 a week, has backtracked to 170 east. The 29-degree isotherm also backtracking some. It was at 172. It's back to about 174 west. The 28-degree isotherm here is at 63 west. That's where it's been. And the good news here is the 24-degree isotherm, it had kind of chopped off out south of California, about 120 west, is now again pushing into Ecuador. All right, so what's all that mean? Well, let's just go take a look. Anomalies, differences from normal for this time of year. What we see is 3-degree temperature anomalies, 3 degrees above normal. This is what is called a Kelvin wave. It's warm water that seeps into the West Pacific, driven by the westerly anomalies of the active phase of the MJO, produces a ball of warm water. It does not travel on the surface because trades are nuking out of the east here. It falls to depth down at about 150 meters down, just like that, travels the whole way across the Pacific, then eventually erupts along the Ecuador coast, creates a warm water slick there. If you get enough Kelvin waves back to back, and it takes 3 months to make the trip across the Pacific, then that is a sign of El Nino. All right, so we have a Kelvin wave. We have another weak Kelvin wave. It's all but erupted off of Ecuador now. But there's a steady stream of warm anomalies across the entire Pacific Ocean, meaning the pipeline's open. Now, this does not mean that we're in El Nino, but it definitely means that we're not in La Nina, and we'll take that any day of the week. Here's another model, the GeoDAS model, a little bit more higher resolution, but it runs a little bit behind time-wise. Anyway, 120 east, this is over in the maritime continent. You can see warm water dribbling into the Pacific Ocean. Here's the date line, 180 west right there. This is Kelvin wave number 6 right here. And here's our warm water flowing east. This is Kelvin wave number 5. This model goes to 80 west, right up to the Ecuador coast. You can see that Kelvin wave from a previous westerly wind burst still erupting, probably pretty close to gone now, but still pretty healthy flow subsurface across the entire equatorial Pacific Ocean. Sea level anomaly data. This is just another way to confirm where warm water might be. Warm water expands, so if it expands, then it would create a bump on the ocean surface. Cold water contracts, it would create a divot on the ocean surface. We're talking bumps or divots in the, a couple of centimeters. In this case, 0 to 5 centimeters high from west of the date line the whole way to 135 west, so about midway to the California coast. Broad area. This is Kelvin wave number 6. Kelvin wave number 5 would be right in here. You can see just the last little tiny remnants of it showing up. Anything north or south of 5 degrees, we're not even looking at. It's not relevant to the Kelvin wave discussion, but all this does is confirm what we saw in the previous 2 charts. Upper ocean heat anomalies. So this is the West Pacific here, East Pacific here. It's sort of a histogram. You can see what happened in the past. Kelvin wave number 4, I think this was here. Let me think. Number 3 here. That is Kelvin wave number 3 a year ago, caused by a strong active phase of the MJO, creating westerly winds that took warm water here, started blowing it to the east. It traveled under the Pacific Ocean, made it the whole way to Ecuador in May, erupted along the coast there. Then we had 2 stalled Kelvin waves during the middle of the summer. In fact, we had cold water setting up off of Ecuador. We thought we were moving towards La Nina. Then magically, for no apparent reason at all, of course, we got an active phase of the MJO, created yet another Kelvin wave. We thought it was going to die like these two. No, it decided to make its way the whole way across the Pacific. This started in, we'll say, early September. Here we are, December. That Kelvin wave is impacting Ecuador right now, creating warm water off the coast there. And yet Kelvin wave number 6 forming now as we speak, being fed by a previous active phase of the MJO. I think it was in the early November timeframe, and now likely being reinforced by this sort of mini pulse of the active phase of the MJO that's occurring now. So a good pattern looking subsurface in the ocean and at the surface in terms of just the MJO and Kelvin wave development. Not super strong, but certainly way better than La Nina. All right, that's all good and fine, but ultimately what matters is the temperatures on the ocean's surface, because that's what causes evaporation if the temperatures are warm enough, and that in turn is what feeds energy up into the upper levels of the jet stream and, feeds the storm track. All right, so the good news is we have warm anomalies off of Peru and even off of Chile. There's Ecuador. There. This isn't a huge area of warm anomalies. If it were El Nino, you'd see this whole region here just cooking warm. We're not seeing that. It's a gentle, warm push, but that's feeding some momentum in the jet stream. We also see the warm anomalies continuing the whole way, it's actually going further to the west than 160 west the whole way to the date line. So a general light warming trend at best. What is the trend? Well, let's see. It's been 2 weeks since we've done this. And 2 weeks ago, the trend was warming off of Peru and Chile. And it's still doing it now, which is good news. And we have light little patches of warming along the equator, 5 degrees north and south. A couple little pockets there of cooling, but generally a neutral to slightly biased warm trend. That's probably about what the jet stream reflects too. A little bit stronger than normal. Not huge. It has its moments. But generally way better than if all this were cold. So what are the actual temperature anomalies for this time of year? We see gentle warming along Peru, not much. We're talking, maybe half a degree or something right along there. We see this pocket of cool anomalies off of Peru, and general light warming in the eastern equatorial Pacific, stronger warming over towards the dateline. Doesn't look like El Nino. Again, we don't see that big red triangle there. But we don't see a big blue triangle either, and that's what you see if you were in La Nina. And of course, La Nina does the exact opposite of El Nino. It really kind of just dampens the jet stream, makes storm formation very difficult. So we're not seeing that, but we're not seeing, basically kind of a neutral pattern biased warm for right now. The actual temperature trend, you can see this in the Nino 1.2 region. So where's that? That's basically off of Peru and Ecuador, the far east Pacific. It's a very noisy region. Temperatures today, 0.2 of a degree below normal, minus 210 right there. The trend, it's actually been colder than normal, not significantly colder. And then we had a little peak of warming here in November and early December. Now we're just sort of chugging along, basically neutral. Now, the Nino 3.4 region, that's the official, El Nino region. Water temperatures there, not much different. Plus 120 thousandths of a degree, 1/10 of a degree above normal. Okay, and it's been hanging in there since early December. We were actually warmer up to 3 or 4/10 of a degree back in October or so, but now we've fallen off. But in all, the trend, you can sort of look at it and goes, yeah, temperatures are warmer than normal, but just incrementally so. All the other data seems to reflect that as well. We're not La Nina. We're not El Nino. You have to be half a degree above normal for 5 consecutive months. We're nowhere near that. So we're just neutral, basically. So what does the atmosphere think we're doing? Are we in El Nino, La Nina, active phase, inactive phase? Southern Oscillation Index will give us some clues. It's the difference in pressure between Tahiti and Darwin. This index has been going on for, I think it's 100 years or more, so it's a pretty good baseline. All right, when the index goes negative, and here's the daily contribution for, like 20 or 30 days, that tells you you're in the active phase of the MJO. When it goes positive, that means you have higher pressure over Tahiti, and that tells you that you're in the inactive phase. And then, of course, when the trend goes for like 90 days negative, and it has to be pretty negative, that tells you you're in El Nino, and of course the opposite for La Nina. All right, so today's contribution minus 0.94. No big surprise. A couple days ago, look, we were at minus 28.27. This was the height of that westerly wind burst. One would say the active phase of the MJO, and we've been negative for, I think this was 13 or 15 days, something like that. So we've been in a pretty good run of the active phase of the MJO. The 30-day average is minus 6.83. If you look back in time, we were at minus 9 there back in December. So we're in the active phase of the MJO, but no significantly strong one. Just run of the mill. 30-day average, minus 7.22 today. Look at past data you scan through here. Yeah, we were actually more negative a month ago than we are today. Certainly no indication of El Nino, but we need to be down at like minus 15. We're not there, minus 7.22. So we're weekly favoring El Nino, so this would lead us towards the PDO discussion. We've had this before. We're not going to get into it tonight, but, that is the 30-day oscillation. It's like the MJO or El Nino, but it runs for anywhere from 15 to 25 years in either a warm phase or a cold phase. We think we're in the warm phase. The warm phase is like a long-running El Nino, and all the data for right now says, yeah, that's probably the case. We're warm, not super warm, but biased warm, nowhere near La Nina. That's good news. Okay, so what is the forecast for sea surface temperatures? That's the ultimate sort of determiner of El Nino. In the Nino 3.4 region, the official El Nino monitoring region. All right, so we're nearly at January 1st. This model, the CFS model, says temperatures, if anything, are supposed to start rising in association with Kelvin wave number 5 hitting the Ecuador region. These temperatures are probably grossly overstated. It's saying 0.7 of a degree above normal, and what are we today? 1/10 of a degree above normal around here. Okay, but the model suggests temperatures rising some, and then a slow fall off into June. Now, here's what's a little bit scary. It says that after June, temperatures going negative into La Nina territory. We actually thought that was going to happen last summer. It held off. It looks like that might be entirely possible coming this summer. If the PDO is in the warm phase, that doesn't mean that you can't have La Ninas, because La Ninas are like 2-year events, and the PDO is like a 15, 20, 25-year event. So you have ups and downs, variations within that. But it looks like perhaps, at least according to this model, we might be moving towards a La Nina scenario. Again, we're talking 6, 7, 8 months out. Kind of hard to take this to the bank quite yet, but something to keep our eye on. So the immediate news is big storm in the North Pacific. Swell is in the water. Swell period 20 to 25 seconds, moving into Hawaii later on Monday, into the California coast on Wednesday, Thursday, and then lingering for days beyond that. Plenty of swell coming. The bigger issue is going to be wind. How do you escape from it? How do you manage the swell size and the wind, and which breaks can hold all that? Then the better news is that swell fades out, and more possibly to build right behind it. So that's good news. Plenty of ocean activity. The snow forecast, literally nothing forecast in California. You have to go north of Oregon. That's where more of the action is, at least for the time being, till the active phase maybe makes its way into California. So, pretty good forecast looking ahead. If you enjoyed the video, for sure, give us a thumbs up, hit the like button. If you haven't subscribed, you're welcome to. Hit the subscribe button down below here on your right. Just put in your email address, and you'll get notifications every time we post the forecast. If you don't want to do that, that's fine too. Just go to stormsurf.com. All the data that you've seen here is present on the site. The videos, links to the videos are also posted up in the banner at the top of the page. We tell you, how to get to the YouTube video. And so that's pretty much it. We hope you have had a great Christmas. We're looking forward to a happy new year, especially with swell in the water. Be careful, enjoy your family, enjoy your friends, stay safe, and we will do this again next Sunday in the new year. Thanks for watching.